Thanks, Bo. Yeah, Halloween did happen. Yeah. So the important part for anybody who hasn't been here before is these meetups are always the last Thursday of the month, and Halloween was the last Thursday of the month. The next month was Thanksgiving, which is traditionally on a Thursday of the month, normally the last one. And Christmas was, Wednesday? So decided not to have web devs those months just for that reason. So anyways, let's go ahead and get started. Val, will you grab the door?
No, I'm busy.
Okay. It's too busy for that. Never mind. Some people are still using it. So anyways, machine learning for the web. This is kind of a weird topic because the web doesn't really do machine learning as far as I really knew for a while. And didn't really come across it until I started playing with machine learning, just trying to do some Hello World stuff just to understand the terms and everything at the very least. Then it came up, oh, well, hey, the web's involved, and I run a web devs meetup, so maybe I should talk about it. So, how many people have done machine learning? A lot? Some? Okay. So, this first part is a lot of basic stuff, so if you've already done it, probably going to be bored. I just want these terms kind of defined so everybody can understand what we're talking about when we use these terms later. So, but it is a very fun and very large topic. This is still a web devs talk, so we're going to be talking about web aspects. We're not going to go deep dive into different neural networks or any of that stuff. We can address those a little bit later. But for the purposes of the talk, we're going to be talking about its application for web applications. So why even do machine learning, at all, right? Because we have problems. And these problems are usually big. And there's a big problem you can solve and make a decision on, and that's hard. So big problems with big data are hard, and they're hard to make a good qualified decision because you can't hold all the data in your head. It's just too much usually. So that's one of the big reasons we use machine learning around for things. I like this definition. It's given a decision where the logic is unknown to us, but we have observations about the decision process, it's possible to use statistical analysis of these observations to create an approximation of the decision logic. So this approximation tells us how we can even approach the problem, especially when it's a really, really big one. Oh, cool, more people. Hey, everybody. Okay, so people already use machine learning, which is fun. And well, what do we use it for? Media, Netflix is using it on movies. Our Netflix recommendations aren't the same because they learn about us. Retail, same thing with Amazon, right? Our stuff is not the same. Sometimes my shopping wish list or whatever I get suggestions for isn't the same as your guys' because they're continuously learning about us and learning about the products, trying to make associations. Manufacturing, this is big for output lines where we're looking for inefficiencies that you can't just obviously see. Instead, look at all the stats and figure out where you can find an inefficiency. Healthcare, clinical similarity between patients is something that's very exciting and I think cool. A hospital can use all of their data and say, oh, these people are having these symptoms. Are they even related? Is there something larger going on? And no one doctor could do that, but a machine can go through all the data and try to figure that out. Finance, fraud detection, so categorizing activities and whatnot that appear to be fraud. Because humans can't watch all the time. We have to sleep, we have to eat, we have to watch Netflix and go shopping and stuff. And science. My friend Zach does stuff. He's a chemist. He tells me he does stuff with machine learning sometimes, but can't really tell me what it was. So I'm just going to take his word for it, that science uses it too. But I know science uses it, so. All right, so these are all really big problems, right? These are really big problems, and these all have lots of data, like your finances and Netflix has a ton of data. Amazon has a ton of data about all of us and a bunch of other things. So they have the resources to do this. But it's still a machine, so it still has parts, and I want to kind of just go quickly over some of the terms here. So there's different kinds of learning, and I'm not going to dive into all of them. Web dev talks are usually 45 minutes an hour, and machine learning is such a big topic, it can go into lots of directions for ever, probably. But the first one I'm going to talk about is unsupervised learning. And this is learning the mapping of some data. You don't really know a lot about your data, and you just throw it all against the machine and kind of see what sticks. And it'll start to look for patterns and stuff. What's an example? Like an example would be like a bunch of images you don't know, and it just finds, hey, this is a pile of something. There's a bunch of circles, basically, and edge circles I can detect. These are all piles. I don't know what kind of piles. They may be rocks. They may be potatoes, whatever, M&Ms. I don't know. But it's a pattern you might not have the time to go through all your images and start to categorize. Supervised learning. This example, hot dog or not, I'm sure everybody's heard of that. But this is where data is mapped and you supervise it. You're going to tell your machine that X, this is X. There's some function to X that's going to give you Y. I don't know what the function is, and that's the machine's job, is to figure out what the function is. So that way when I give it a new X, it'll spit out the Y that corresponds to that, what it's learned. And reinforced learning. This is an example, so it's trial and error with a feedback loop. So you have to tell the machine if it did well or not and have parameters of what is good and what is bad. This example is teaching Mario, or the machine to play Super Mario World. And in this example, good is a function of how far you move to the, to the right and not die. So the machine tries literally everything it can with all its inputs, and that's what all those little nodes are. It's trying to map, I tried this here and that there, and then there's a visualization. But the important part here is the feedback loop. You've got to tell the machine that it did well or not. So general terms, let's go over some general terms. Data set, that's pretty straightforward. It's a collection of examples. Training, that's the process of determining the ideal parameters comprising a model. And a model is a representation of what a machine learning system has learned from the training data. So these are like the most basic parts. Like everything has all the kinds of learning. Feature engineering, this is creating prediction variables. So especially when we want to know what something is, make a prediction, we're going to need variables. Classification, that's basically labels for these predictions. And loss. Loss is also called cost. And it's a cool, interesting concept. So like, the loss is the number indicating how bad the model's prediction was on a single example. So in these examples, you see the two charts. The blue line represents all the right answers, and the circles represent all the machine's guesses. The red arrows are the loss, or cost. I'm probably going to call it loss for the rest of the time, because that's what I've been calling it. But that is how far off it was. And this is an interesting thing because, well, one, because they're all represented with a whole number. It's 0 up, regardless of which side the line's on, and that's a little counterintuitive to me, at least it was. The other thing is, this also is, you don't necessarily want them all to be exact. Your model may be then overfit and is too trained on your data. And so it's an interesting concept that I don't necessarily want my model to be 100% all the time. Like that's probably overfit. And of course, it can't be like 10% all the time, that's underfit. So there's like, you need to have some wiggle room for it to be useful, I think. So common machine learning frameworks, most of these are going to be Python. TensorFlow is going to be the big one. And I'll come back to TensorFlow in a little bit. But yeah, Pandas, if you've heard of that, NumPy, PyTorch, PySpark, and of course there's ones for every language, and there's ones for basically every platform, including cloud. So Amazon SageMaker and Google Cloud ML Engine, their creative name. But yeah, so you have lots of options, but even in this, if you're looking at it, you can probably tell most of your options are going to be Python. So today's talk isn't really going to be about Python because it's for web devs. But I'll come back to Python here at the end of it because that's still an important part if you want to keep going in machine learning. So another really important thing is pre-trained models. So somebody else has done some work for a pre-trained model. They've trained a model to do something, and you can piggyback on that. And this should be very familiar for web developers because we get libraries. You know, I don't make an AJAX call, writing an XHR request. I use Axios. Somebody else has done a lot of the work for me. I piggyback on that, and that's how I make my REST calls. And before that, we had jQuery for the same task. Same deal. We have something that somebody else has already started, hopefully documented very well, and then we can piggyback on that and move along and get further on in our project, and decide if we need to make one from scratch later. And that's going to be with JavaScript, because this is a web dev's talk. So, like I said, Python's definitely going to be the language to go to when you graduate beyond the stuff and get more serious in the stuff, but for right now, we'll just talk about JavaScript, because that's pretty much what happens in the web everywhere. So I decided to get started with this framework, Brain.js. It was very simple, very approachable, wasn't a whole lot to it. It had all the same terminologies I just went over, so I got to actually play with them a little bit and try to understand what they mean when they say these, whatever these terms are, loss and all those. So what did I do? First off, Brain.js is a GPU-accelerated library of neural networks written in JavaScript for browsers with Node.js. I was pretty skeptical about the browser part, so I didn't try the browser part. I only did the Node.js. And so, what did I try? A movie gross prediction based on a string containing a genre and names attached to the film. So, like I said before, problems, right? I'm not going to do this. I don't like Hello World, so I'm not going to probably do it unless I have some sort of problem or project to try. So here at IDX, we have a inter-company recreational thing where we have a movie draft, and it's basically finding fantasy football for movies. And the points are instead the gross the movie does. And I don't really watch a lot of movies, but I was like, well, maybe I can make something that'll make predictions for me. And then I can play. So that's what I tried. Here's the data set I decided to assemble from just the simple text I could get from IMDb. This is going to be the genre, the director, and the stars. So X-Men is one of them from the data set. I did 30 years or something like that from IMDb. And it did 157 million gross, which I round down in my category to 150. So this is a $150 million movie. And my bet here, or my thought here, is that it's because of directors and actors. Big name actors have box office draw, big name directors get resources from movie studios. So I'm counting on the movie studios to do calculations on their own risk analysis, and I'm just going to piggyback on that in a very, very oversimplified way. So my text is action, adventure, sci-fi, Bryan Singer, Patrick Stewart, Hugh Jackman, Ian McKellen, and Famke Janssen. Those were the stars of the movie as listed at IMDb. Again, I don't want to introduce my own bias. I'm like, I don't know, Bryan Singer or something. I'm just, whatever. So I run it through, and now I want to give it a new movie description to solve, or to predict. Yeah, hold on. They do not. So I had to write a script to acquire the data. So I already have the problem of data acquisition because I don't have enough data on these movies. I don't keep track of these things. So I have to go get it from somewhere. Again, I think this is what a lot of I find is a barrier to getting started in machine learning, is having enough data to even really play with. So even this isn't very much, but it's just I'm playing machine learning. This isn't real machine learning. But my new movie I want to introduce is an action movie with Jackman and Singer. So I have the genre, the director, and only one star this time. So this is how much code I had to write to get started. And this is all in JS. I don't know what that sound was. Okay. So I'll just go through it. It's not many lines, 15 lines. So the first variable is the library, obviously, const brain JS, required brain JS. Data is my movies, which I have arranged in JSON. It's just an array of objects with the text in the category. The network is recurrent LSTM, long-term short-term memory, and that's a type of neural network. I chose that one kind of arbitrarily, but then I looked into more at this time, and I was like, yeah, that makes sense, sure. Like I said, I'm not going to go dive too much into the neural networks. There's many kinds, and it's a little much for the web devs talk. I'll be up here for 2 hours or something. The training data. So this is me mapping, iterating over my data that's in my JSON and fitting it to, or just changing the key really from input to output, input and output from what it was. So cool, I have my training data, I have all this stuff. This is all going to happen right here and in this one script. I'm going to train my data. My iteration is going to be 100, so it's going to go through 100 times, calculate the loss down to whatever its preset. It's a framework, so like all frameworks, you accept values set for you. Whatever the loss threshold is that it's going to go down to, it's going to do it 100 times. Now I'm going to pass in my movie, which is action, Bryan Singer, Hugh Jackman. The output's going to be, after it runs through the machine learning framework, and console log the category and the output. So how well did it do? Brain.js predicted 100 million, and X-Men 2, the next movie that would fit this, did 110 million. And I was like, yay, this totally works. I can play now in the movie draft and not have to watch movies. Yeah, what's up, man?
I had a question about the iterations thing, since you have your set of that data already. So it sounded like you're iterating all the way through that data, and then you're going through the same data again. And so what is it doing differently? Is it like trying to, my understanding is maybe it goes through once, now it tries to make a prediction and see if it was right the second time through as if it was new data? Or?
Yeah, it's pretending it never saw it before for the most part, and then compare it against what the answers it knows. And it does it over and over again. And because the math has tiny fractions of difference as it goes through the neural network, they're slightly different sometimes. So your loss numbers will be different sometimes. They make it close enough to the threshold. Sometimes they're over the threshold, so it stops. Sometimes it's a little under, but it's close enough. So that little thing is how it's trying to calculate the wiggle room that I was talking about earlier.
And so that would be the thing where if maybe you got that number too high, that's where you'd get too tight of a fit.
Right, right. If you're trying to get like super close to 100 every single time, it's probably too tight of a fit. Yeah.
Can you go back a slide?
Sure.
Here, when you see the movie that you're going to evaluate, which is acted Brian Singer, Hugh Jackman,
Yes.
is it the presence or absence of each of those things that is the feature? And so, you say there's a feature which is has the string action, or the absence of has the string action. And does this thing only build up that first order interaction, such as has action or not action, or is it second order things like has Brian and Singer?
Or the order of it.
None of those things. This is a very oversimplified way of representing this, and this is just one feature, and the feature is a string. So I didn't break these out into their own features. As you notice, there's nothing separating them except for spaces. So in all actuality, spaces is part of the feature, right? Which is not really good data. It's noise. I'll come to that in a second, actually. So yeah, that's actually where I'm going to here. My data wasn't great. The data I fed it. The data I fed it wasn't great. So like you pointed out, I have everything there. It's not a bunch of features. Like the director may have more box office pull than an actor, and if it's a new one, that's fine. But I don't have them separated. It is just literally a description in one string. So that's also noise, right? Like I said, spaces. What if the machine starts thinking the spaces are a good thing, and the more spaces there are, or what if like there's a movie and there's 4 people in it named Paul and it did really well, and they might think, well, Paul is what people want to see. Because it doesn't have biases like you or I, it's just like whatever you gave me. So I prepared my data poorly in here, and this is one of the things I learned here, is I'm not good at this. At least not yet. I need to, data matters most, and that's the thing I needed to take away from this, is I need to prepare my data in a way that the machine can actually make connections more accurately, as opposed to just randomly with whatever in a string. I prepared the data in a way that made sense to me as a human, but I'm trying to get a machine to learn. So data matters most. Verification takes thought. Like I said, I got this result that looked like it was like some sort of indicator that I was on the right track, and it's like, well, it happened to be close. Other ones failed. Other ones failed for other reasons, like I didn't take into account that there could be 2 directors on a movie, and that might make a difference. And like I said, the spaces, I had noisy, not very well prepared data, honestly. Debugging can be hard, I noticed, because a lot of the stuff happens in between, and it's more like I have a thing I'm trying to get to, and I'm trying to get to an output, and in this framework, I don't have a lot of insight into really how the machine works under the hood. It's more like, and that's why I said I'm playing machine learning at this point, for the most part. I need more practice with this. That's another thing I learned. And it was fun. It was just an interesting exercise to do, like, because like I said, I don't like Hello World, so this was more interesting and had potentially a practical thing, and it was fun to play with. I don't know, it was 25 years, I think, so whatever came up on the first couple pages of IMDb as I went back in time, and I don't know that was a set number every single time, because I just let the machine... I think there was at least 100 for every year. It might have just been the top 100 every year. Yeah.
Just out of curiosity, how long did that run when you did that script you showed us?
So running that 100 times took, I think, a couple minutes, which isn't that long.
Yeah.
But then again, I only have, 2,000 things, and 2,000 things is not a lot of things for a machine. So I really have a pretty weak data set and a terrible representation of it, and that I ran it through the quickest framework I could find. So this is me being, like I said, just trying to go through something to have a project to work through. And it was in Node, so I didn't have to, and I do JavaScript here at IDX, so I was like, yeah, this will be faster, even then, in that regard. So yeah, sorry. Then I tried, so then I was like, okay, well, I caught wind of this framework, ML5. ML5 is a higher level framework for TensorFlow.js, and I was like, oh, okay, well, this sounds better, because now TensorFlow is involved, and TensorFlow.js is a implementation of TensorFlow entirely in JS. It's not like it runs the Python normal TensorFlow.js at a higher level. It is just TensorFlow, but written in JS. So I was like, cool, let's try this. And I learned a lot about this. Here we go. I learned a lot about what this framework's trying to do, and what it's trying to do is be a web framework for machine learning. And when I say web framework, I mean for web pages. Like, it is trying to do that. So much so that it is kind of coupled loosely with p5.js, which is a DOM manipulation framework, kind of like jQuery-ish, not really, but not as slow. But so there's lots of things where you can just write very little code and get machine learning in JavaScript, and browser-based as well. So I tried image recognition, because the hot dog thing's fun. And I was like, image recognition, okay, that's cool. It's a lot easier to get a bunch of samples of data really, really quickly with image recognition because I can just use a camera. And cameras take, lots of frames, like 60 frames a second or more, or whatever I set it to. So this is the demo part. I hope it works. If you have your phones, you can go to this webpage, and it should do image recognition already. And this image recognition is a pre-trained model. So this was very easy for me. It is just going to try to just guess objects. And if you're sitting in the couches, I put some objects out. That was not a terrible breakfast that I set for you guys. It's actually stuff that you can try and see if the phone will guess it. So interesting thing about this, the model it creates is a small bit of JSON, just a quick JSON file. The weights that go along with the model are about 5 megs. So all of that's being shipped to the browser. You have to get pretty close, just so you know. Like, because it's an image recognition, recognizing the entire image, you kind of have to be, the image or the thing has to be the main focus of the image, and it guesses over and over again. So sometimes it's right, sometimes not. Point it at whatever you want, it'll just try and guess based on that, that pre-trained model. Yeah, I put out objects that I know it can recognize. So feel free to play with that. But I'll talk some more about why it's cool. So this is cool because it is all in browser. All of this is happening in the browser. Like, the page I sent out is just an S3 page. There's no processing elsewhere. There's no sending it back to a machine, to a Lambda, to an EC2 instance. Instead, all of the guesses and stuff are happening using just your phone's hardware. If you turn off the internet, it continues to work because it's all in browser memory.
So where's the data? Pre-trained model?
It's a pre-trained model, yes. But it's small enough to ship to you really, really quickly. And I think that's really the cool part of this. Oh wait, let me go why it's cool, yeah. So ML5 at a high level is running TensorFlow, and I'll show you some of the functions there because it's really, really small. It's not smaller than the Brain.js because there's more web page stuff involved, and that's where the p5.js comes in. You can do web page experience stuff, it's like anything you can do in a web page, and I have another demonstration later. But it's also not cool. It's less than cool for other reasons. And most of these reasons are the same reasons every browser has. It's just the web. So JS loading takes time. This framework is not, it's not huge, but it's also not very small. So the load times are, it takes a bit. You probably should be on Wi-Fi if you want to use this. That's why I put out the Wi-Fi password. It works fine on LTE, at least on my phone, my old iPhone 7, so I don't have a new phone or anything. Works fine on LTE. It does take a second to get going and for the model to get into the browser memory and all that stuff. But it works fine. 3G is not going to be a good one, so if that's a constraint, probably not viable for you. Your model does have to be kind of small. Like, you can't go overboard with this because it's just more space and trying to ship this to you over the internet and all the other normal browser limitations. So one of those, I did a talk on augmented reality in the browser, and one of the big limitations was the streaming of the camera to the browser, because that is controlled by the OS. So that means if I'm on iPhone, I can't use Chrome, even though I prefer Chrome over Safari. I have to use Safari if I want to stream the camera to the browser, and that's just decided by iOS. Same thing with Android, you have to use Chrome. I didn't test in Firefox, but other browsers that are like what's one that is about the privacy, DuckDuckGo as a browser, doesn't work. I think so. Somebody told me that, and they're like, oh, it doesn't work. It's in DuckDuckGo. I also didn't try on a Windows phone, but I don't worry about that anymore. So normal browser limitations. So at this point, simple guesses about simple things it's seeing is happening all in the browser, and I think that's the cool part about this, and I could ship it just over the internet on a web page. Yeah? You have a question? Oh, I thought Melanie had a question. You want to make one up? No, I'm just kidding. Yeah.
I wasn't seeing any other interface. I'm just seeing the image on here. Is it supposed to pop up with something when I identify something?
It's in the bottom. It should try and identify anything, but it's just writing in the bottom, at the very bottom left, I think, just white text over the image.
Okay, I guess it hasn't identified anything yet.
So that was another thing. Again, all browsers have this problem. Things you want to do may or may not work on all devices. iPhone's pretty easy to nail down because there's just only a couple versions of each version of it. But Android devices tend to be a little bit different depending who makes them. So like when I did the augmented reality talk, I had the same problem then with Josh's phone, where his phone always thinks the back camera is the front camera. So in this example, I set out the JavaScript to say, use the back camera, because I'm trying to get you to, the experience is to identify an object. So I need you to use the back camera because I don't want you to turn it around and then not see the guess. Doesn't work on his Android phone. It's the opposite. So works great for the augmented reality face thing, but yeah, actually it didn't because it turned it around. That's right. Never mind. Didn't work.
Weird.
So the code. Here's all the code. Go ahead and read it. Just kidding. I just don't usually like reading code, so it's a passive-aggressive move on my part. So loading all this stuff is just like any other web page. It comes from a CDN. And so I'm loading this just like I would like Bootstrap, loading like I would Axios, any other framework I'm going to load on a web page. These are on Cloudflare, and the first three are P5. So this is the DOM manipulation I use to make the page. The last one is ML5. The last one is the machine learning JavaScript framework that runs TensorFlow. So those are just thrown in the head. Cool. I have something ready to start, again, playing, because these are very simple things. So in the setup, I use a function called setup because p5.js will run things in specific function names in specific order. So you can have a pre-setup. P5 will go and make sure that runs before to take care of like asynchronous stuff. So setup is the default one that always runs at the beginning unless there's a pre. And in here, all I really have is defining which pre-trained model I want to use and the source. So I'll just go through it real quick. So I create a canvas so I have something to cast the video onto and get from. My options are cam choice, and I determined that by the width of the screen, so everyone should have got the back cam on their phones if it worked. And that's my cam choice, and that again is a P5 thing. The video, create capture, so now I'm asking for, this will initiate the question of, can I use your camera? Which should everyone, you have to give that permission. The video, I hide the canvas because I don't want you to see it, I just want you to stream. And then MobileNet. MobileNet is the pre-trained model I used. So I didn't take pictures of bananas or cups or anything else. MobileNet has done stuff like that before. They have a whole open source list of images all the way to like penguins. Like I don't know who's in Antarctica like playing this with penguins, but whatever. That's their pre-trained model. Then I have an image classifier because that's what I'm trying to do here. I tell it I want the MobileNet and the video, and then I have a callback function for when it's ready, just so in the console I know this is ready. And then it just starts going for the most part. The machine part at least starts going, the learning or the guessing part, I mean, because this is already learned. So the guessing just starts. I did not do any of the training yet. The model gets going and it just reports out that it's ready into the console or wherever I put this. And then it starts to predict. And every predict is a callback function with its prediction. And that's got results. You can see it there in the predict. And then I console out if there's an error. Otherwise, I'm going to get the label that it's predicting. I have a set timeout because it doesn't need to predict that fast because you're not going to read that fast. Also, I found, man, your phone gets hot when it's doing every frame. And your battery just goes down really, really fast because you're processing literally every frame as you're streaming it. So then, yeah, set timeout, and I just report what I'm trying to match up, and that's what goes to the front end. So there's not much more than that. Everything else other than that is just normal web page design. You know, there's a head, there's a body, there's a little bit of CSS to align it. Nothing else is it. All the machine learning has already been done for me in this pre-trained model, and all the setup stuff of getting it going is pretty much done for me. So this is also, like Brain.js, was a great way to get going again, but this time without my bias and my ignorance on how to set up the data that I was going to feed it. Instead, I have a pre-trained model. Now I can start thinking more about the output. And that's what I think this gave me a lot of insight into. It's very simple to use. It's image recognition for everyone, so that's fun. It's good. It's, again, all in browser. If you cut the internet, this thing continues to try and guess. Also, limited by phone capabilities. And this is not a lot of machine learning. This is a lot of leveraging libraries to do something that machine learning has provided, which is the model at this point. And bugs are hard because I didn't really know the P5 framework as well as I thought I did, and bugs are either in that part of the framework or possibly in, because I'm trying to pass the video stream there, and that was a problem, especially with some phones. They don't all process things the same way. Some of these different versions of WebGL. So all of a sudden I'm like, oh, where's the bug? Is it when I'm trying to capture a WebGL, or when I'm passing it to the TensorFlow JS via ML5? Sometimes I couldn't find out on certain phones. So I learned to have some empathy for the machine, though, because images can be hard. Humans get fooled by images, too. This is a sink. It looks like an eyeball, and it's totally not. But dealing with the output and dealing with the machine trying to learn or trying to guess on various objects, I started to learn, okay, I need to set my output expectations accordingly, too, if I want to understand this process from beginning to end. So in playing with all these things, I found some other interesting libraries specifically for web development. These are use cases specifically for web pages, or one of it is. And this is called Guess.js. And this is not image, it's not prediction really. It's prediction, but it's not prediction on human stuff. This is prediction based on data that I didn't have enough to really get a good example with, but I wanted to mention. So this is machine learning driven user experience on the web. This is more predictions. As I keep going through all the web stuff, it's pretty much all predictions, because web is really trying to deliver an experience. An experience can be enhanced by predictions. And this is trying to predict the next page or pages. So I'm not going to read all this stuff. I'm just going to go through, just give you the gist of it. So what the aim of the framework is trying to do is trying to predict the next page on a very large web page. On a small web page, you have 10 pages. Yeah, whatever, it's fine. But on a very, very large scale, if you can reliably predict the next page you're going to, you can start loading up JavaScript before they get there. And this is really cool for a single page app or a progressive web app where your JavaScript's being loaded because it's anticipating the next load, and the user doesn't know. The user just knows that the next page was lightning fast for some reason. Or doesn't care, it just doesn't care that it's lightning fast, but loves that as opposed to it being slow. So that's really their aim here, and not just with JavaScript bundles, but even the next content. So even if you're loading up other resources, even a whole widget or a bunch of text or other images even, you can start to try to predict it. And the way that this framework is trying to do it is by hooking into Google Analytics. So this also solves the other problem I really had before even trying machine learning was, where do I get enough data to start trying? Well, if I have a website that's been around for a long time, I have a whole bunch of data from Google Analytics, provided that I set it up in the first place. But it can connect directly to the Google Analytics API and start using that as the data for it to make its predictions on where your users are going to go next, when they're going to go there next. There's all sorts of dials and stuff to say, well, do I want to load immediately because I think they're going to go here? Or if they're on a page for a certain amount of time, do I then want to start loading my JavaScript bundles and my next awaiting resources to improve the speed of their experience? And this is all coming down to using the user experience driving this. And you could do this, we already do this with prefetches when we know that there's probably the next page being hit up or whatever. But the cool part about this is that means that the prefetches are not hard-coded, and if a human does it, they're probably hard-coded in. This will continually just learn and always be on watch of which prefetch should be next, and then a human doesn't have to do it. So for like I said, the problems in the beginning that were being solved were very large problems about very large data sets. And these problems are, for the web, I think are becoming, instead of being a large problem, it's a continuous problem. And I need a machine that can learn continuously and adapt as things change, so I don't have to pay a person to follow up every 4 months, look at Google Analytics and say, now change the prefetches because we had a sale, we're going to have a sale on this or that. It should just happen automatically. And the real goal, I think, after this is to then probably drop a cookie in there and start having even more personalized prefetches in the browser. So yeah, widgets too. So this is good for ads. This is good for all those, anything in the sidebar on a web page that people may interact with. Just start loading things up before they even get there so the experience is faster. So actual use, when it's be easy, yeah, it's all pretty easy. You can use it, it's all JavaScript. It's really easy to get started with, it's not hard. The hard part is the concepts, the hard part is understanding your data and understanding what you're expecting from it. But the only real barrier to getting started with this for a web developer, I would say, is the normal browser stuff we have to deal with all the time, which is browser compatibility from this device or that device, especially if it's mobile. So back to ML5, real quick. So you mentioned the training. I didn't do any of the training of that first one because it was a pre-trained model, and that's cool. But I did piggyback on it and train it again. And this is just a web page I created, and I put in my labels, and I can add a new image and over again, and then I can train it and save the model, pull it out, and then send it to wherever I want. So I did this, and I did the image capture, I did the image training, did some quick guesses on it here, and then saved it, all in the browser. And while that worked fine, the browser did complain after a certain number of images that it was storing in memory. So it was like, yeah, I'm starting to get a little full here, buddy. And then after it complained, when I finally hit that threshold, I told it to train. It trained, and it trained pretty quickly. I think it was about a minute or so before it had a trained model on 3 different objects that are in here right now. And I think I loaded like 500 images for each. So not that many images really. Took about a minute. Again, I had the browser running, and it was other stuff was running too, because that's how machines work. But I did it all there, saved it. So all I really had to do that, to train, to piggyback on something and train, was change this from a classifier to a feature extractor, and then have classification afterwards. So I need to add new features. Then I need to do the classification. So again, the video was the source here. I have a video ready, model ready. That's stuff like I had before. And then there's a simple, easy way to add an image. There's just a function I call, and I pass it the image. All I have to send is the label, because it's going to assume that the source I said in the first place is the source, so it's going to be the frame that I captured when I push the button. So I'm not really changing much of that code from before. Everything else around it is going to be, again, just web page HTML stuff. And then I hit train, and train's just a function. Train is, and here I can set, I'm reporting the loss value. I can do stuff if I want to do something different with the loss value or not. That's up to me. But again, it's just simple JS in a function, and I show the loss in the beginning of that web page that I had. And then, yeah, I trained 3 objects in the room. Your phone can identify them. I'll give you the URL for that if you want to. And if you want to go to this URL now, you can, and you don't have to do it now. But there's, yeah, 3 things in here, and if anybody can tell me the 3 things, I'll give them an IDX hat. I got 2 of them. So that was me training a model, and I learned a lot about that. Capturing the data is interesting. This is an easy room to do. It's pretty much the same when it comes to images. It's pretty much the same lighting, pretty much the same stuff all the time. Trying to get something dynamic that has a dynamic background on it, or that doesn't have edge detection to tell me that it's a banana or a cup, is a lot harder and takes more training and more data preparation beforehand. So I've been saying about playing machine learning. So what about real machine learning, right? I like this image because it's a toucan eating Fruit Loops, so it's real. But TensorFlow, this is supposed to be under an hour. And I felt like it was, first off, it's a disservice not to mention TensorFlow in Python, but it's also a disservice not to talk about it more. So I want to talk about TensorFlow as well more, but I think I'm going to do that at the Python meetup in March. And that's not going to be any web stuff. Instead, maybe take something of this and then redo it in TensorFlow, so we can have 2 examples, like maybe the movie one, or maybe one from here. I did do a similar thing. I did a talk here at IDX internally, and I use our IDX data in a better way than I did with Brain.js to show, what was I looking for? I was looking for retention times for our customers. So all of a sudden these business applications started to come up and everybody was really interested, and they're like, oh wow, you can maybe predict how long we have a customer depending on the features they use in our product. And I'm, well, yeah, probably. We didn't come with a prediction. How solid it is, that takes a little bit of work, and I'm not going to use any of this for that.
Yeah.
This, on the other hand, is fun. And it is fun saying that this is a banana or this is a cup. But yeah, that's about it for the web portion of it. And if you want to know more about the TensorFlow, like nuts and bolts stuff, under the hood stuff, come to the Python meetup in March. And yeah, you can do the fine thing if you want to and go around the room, but that's my talk.